Hi folks, here's 2020 Leaving Cert Higher Level Question 9 on equilibrium. So we can see here 9a, standard sort of questions, they always ask your definition. So you need to sit down and write them out. So what is meant by chemical equilibrium? It's when the rate of the forward reaction equals the rate of the reverse reaction. Why is it described as dynamic? There's reactions continually occurring. Products are forming reactants, and reactants are forming products at the same rate. Hence state Le Chatelier's principle. When a system at equilibrium is subjected to a stress, the system responds in such a way as to minimize the effect of the stress. So you have to know those. If you don't know those, don't even attempt the question. Like 14 marks out of 50 there, you're 38% or 28% of that question there. Only other one you're probably missing there is a reversible reaction. A reaction which can take place in either direction. Now we're asked there to find Kc. So Kc is my products over my reactants. So I've got my CO2 over, or times, I forgot the hydrogen there, over CO times H2O. There's no powers in any of these because there's no numbers in front of them. So that's the only case if there was a 2 in front of H2O, would be H2O squared. Don't have pluses and times in them. And we need our square brackets. Our square brackets means moles per litre. Part C, so this is the more difficult type of the calculation where they give you the value of Kc. So if this, I've got a dreaded grey box in this, I'm going to have to write out your equation here. So CO2 plus H2O. I'm just writing out this equation, CO2 plus H2. Now you might see different headings. I always just learn them off. So you might see right, use it if you want. So I've got moles initially. Change. Moles at equilibrium. And equilibrium concentration. The only thing different there, it's in moles per litre. So excuse my bad writing and all. I've got trying to squeeze this all in, which is a disaster. So now you've got to look back up and see how many moles initially they give me of each of these. So when 3 moles of carbon monoxide and 1 mole of steam, which is my water, were mixed together in a fixed volume V. So 3 moles of carbon monoxide, 1 mole of water. Haven't told me what I have. There's no products initially because they're starting off at 0 and then they're going to increase. My change, this is with the ratio. The ratio is 1 is to 1 is to 1 is to 1. So when they give me the value of Kc, I'm writing it in terms of x. So my change there is minus x. And my products are increasing x and x. If 1 was a 2 in front of it, it'd be plus 2x. What have we got now? We've got 3 minus x, 1 minus x, x and x. And since I've got no volume, you can write it over v, or I just leave it without it. If they said 10, you're going to have to write it over 10. Now they said the value of Kc was 4. The equilibrium constant is 4. Never mind the temperature, it's just Kc's temperature dependent. So now I'm going to throw in these values. So my Kc is 4. It's my products over my reactants. So we wrote out the Kc at the top. So there's my 2 products over my reactants. I'll let that equal to 4. Tidy it up, multiply them out, x squared. Multiply out your bottom, bust your brackets if you need, split your brackets. Whatever way you can multiply those out, multiply them out. Maybe tidy up that bottom line a little bit. Now from here, what I would do is cross multiply. So 4 times all that thing in the bottom. And then tidy it up, starting to look like your old friend the trinomial, the quadratic. Bring across the x squared, change its sign. So you've got 3x squared minus 16x plus 12. Now I wouldn't even bother. Open up your brackets, go straight into your minus b. So a is the number in front of x squared, which is 3. B is the number in front of x, which is minus 16. C is the number at the end, which is 12. Now your minus b formula, minus b plus or minus the square root of b squared. Write it out, I've just tight for space. You need your brackets around your minus 16 squared. Otherwise you might get a math error. You'll definitely get the wrong answer if you don't get a math error. Minus 4ac all over 2a. Now when you type that in your calculator, press your SD. One of my answers there is 4.43. Pop and change the plus back to a minus. The other answer is 0.903. Breaks my heart, just right one decimal place there. Now we've got to determine which one is right. So plug each of these back in up here. So both of them could work for your x and your x. But if I fill that 4.43 into 1 minus x, it's not going to work. So we discard that. So we're going to use our value of x to be 0.903. I don't know what they've asked me again. So calculate the number of moles of carbon monoxide in the equilibrium mixture. So carbon monoxide is my first reactant I wrote down. So it's 3 minus x. So 3 minus 0.903. And when you put that in, 3 minus 0.903, I'm getting 2.097 moles per litre, again, or moles per litre, whatever you like. Now they're just looking for that answer, 2.097. Good, didn't work out the worst. Predict the effect, if any, of adding more steam on the value of Kc. So it's a common question. They often ask you what happens to the value of Kc. Now when they do that, Kc is only affected by temperature. So the effect of adding more steam, no effect. Kc is only temperature dependent. And on the yield of hydrogen, so if I add more steam, my steam is my H2O. So if I add more of this, I'm just going to use Le Chatelier. I increase the concentration of water, the system responds in such a way as to decrease the concentration of water. Equilibrium shifts to the right, forming more product. Therefore, increasing the yield of hydrogen. Have a guess, have a punt. You've got a 50-50 chance. Say what way the equilibrium goes and say what happens to the yield. And state and explain the double whammy on the value of Kc of increasing the temperature. Now when you increase the temperature, you favour the endothermic reaction. Now an endothermic reaction is determined by your delta H having a positive value. So when I see this as delta H is minus, that means that forward reaction there is exothermic. The backward reaction must be endo. So if I increase the temperature, my equilibrium goes to the left. I'm very much on the reactant side, so what's going to happen to my Kc? Kc will have a smaller value, will decrease. So when Kc is bigger than 1, the bigger the value of Kc, the more on the right hand side we are, the more on the product side. So if we decrease, or if we increase the temperature in this particular reaction, equilibrium shifts to the left, Kc will decrease.